All right, class. If this was one of your recommended videos for the Unit 6 quiz, then it meant that you missed something more to do with just looking at relationships and being able to pick a correct choice as to what type of relationship was being described, or being able to explain why the relationship was showing up. So, some of the things, let me just kind of sketch out. One of the things that I would suggest is when they give you the real life scenario, I think it's a good strategy to try to sketch out what a scatter plot would look like. For example, let's suppose it was like a student's height and their final exam score. And you're trying to determine if there would be a correlation, and if so, would it be positive, would it be negative, or would it be just like no correlation? So, first thing is just try to identify what the variables are. Like in that case, it would be height and final exam score. So if you just imagine sketching out a picture and putting height, I'm just going to abbreviate HT, and then putting final exam score, then you kind of reason through, hopefully, once you try to visualize the relationship, that, people could be short, so have a height down low like this, and short people can get high exam scores or even low exam scores or kind of middle exam scores. I mean, short people could do that. Middle height people could get exam scores all over the place, and tall people. In other words, it's not like you would want to think that short people are only going to get low exam scores or vice versa. So when you imagine that, hopefully you would realize, well, wait a minute, this is really not going to be a significantly positive or a significantly negative relationship. It's going to be more of one of these horizontal relationships. And remember, when the scatter plot shows a horizontal pattern, that basically translates to mean no correlation, because the best fit line would be something about, some sort of horizontal relationship. And that means as the X's are changing, the Y's are not really changing. In other words, there can be a lot of variation in the Y values regardless of what the X is. So this would be a scenario that would be showing no correlation. On the other hand, if you get something like, let's suppose it tells you that it's just children, ages 1 to 12, and you get something that talks about the length of an arm and the height, for example. Well, with that, you have to read the words in the problem. You can't just go for the numbers or the variables. You have to read the words, because if it specifically said these were going to be people ages 1 to 12, the key thing you would want to pick up there is that that's children. They're growing. So that someone with so let me let this be length of arm, and this one be height. So, if somebody has a really low arm length, then they're probably very young and also probably have a very low height. Or if someone has a much longer arm up here, then they're probably taller because they're older. So hopefully you can reason through that this would result in something more like this, and that would be a positive correlation. Again, I just think it helps to sketch out what the scatter plot might look like, especially in those problems that they don't give you the plot. All they do is give you words, and you have to try to figure out what type of correlation. Other things, if you had this as a recommended video, would be to look at why we're seeing the relationships. And typically there's 3 main reasons why we could be seeing a relationship. It could be total coincidence, it could be an underlying cause, or it could be a direct cause. And, so let's look at something like this positive correlation that we would see. Well, somebody's arm length does not guarantee they're going to be a certain height. I mean, think about it. We can have, some people could just have unusually long arms or unusually short arms. Your arm does not perfectly determine what your height's going to be. But in this case, the reason we would be seeing a positive correlation is an underlying cause, and in this case, the underlying cause would be age, because age is explaining arm length. In general, the younger they are, the shorter the arm. The older they are, the longer the arm. And age would also be explaining height in the same way. The younger one somebody is, the shorter they are typically. And the older they are, the taller they are typically. You know, we have to say typically. And remember, these are just children. So while adults can be all different ages and all different heights, these are growing children, and that would be important to pay attention to. So the age is affecting both of these variables, and that's explaining why we're seeing this relationship between these two variables of arm length and height. So that would be an underlying cause. Something that's more of a direct cause would be, you know, something like, and I'm just going to make up something, like there was something out there with gas prices and things like that. I mean, basically, if the price of something goes up, there's going to be an immediate response to that from consumers, and that is they're going to buy less of it, you know, because in general, people cannot afford something if the price continues to go up and up and up. Well, that would be something that's more of a direct cause. In other words, if the price shoots up drastically, you will see an immediate effect with, you know, with if the price shoots up drastically, you would see an immediate effect that people are going to stop buying that product. So that would be more of a direct cause. So just try to distinguish between an underlying cause, which is another variable that was not part of the two that were addressed, or a direct cause really means that you're going to typically see that the X directly affects the Y. And like I said, that would be things with prices going up, or you know, something like if you changed your thermostat, that would be an immediate effect on your heating bill or, you know, power bill or something like that. That would be direct cause. So you just want to try to distinguish between those things. So, you know, you're definitely going to see things like with gun-related questions. You know, the guns themselves don't immediately lead to an increase in murder. I mean, the people will have to be involved, but certainly there's an association there that, you know, if more guns are available, then we could very well see an increase in gun activity, but the guns themselves are not causing the murders. So anyway, but hopefully that's enough to think about to help y'all with these questions that are talking about what kind of association, what's causing it. You know, is it underlying cause or direct cause or totally coincidence? And then you get the ones that say, is a causal connection valid? Well, I mean, with that, you have to look at, you know, like something with study, how many hours you study and your exam grade. Even though there are other things that can affect your exam grade, you know, certainly hours that you study does tend to translate directly to how you do on the exam. So even though there can be other variables, we typically would see that when someone studies more, they do better. And therefore, a causal connection would be valid. That's not to say that study hours is the only thing that affects it, but when you tend to see a trend, a direct trend, regardless of, you know, even though there might be a few exceptions, when you tend to see a direct trend, then you want to say that, yes, a causal connection would be valid there. So hopefully that's helpful for those types of questions that are kind of the non-mathematical questions on the quiz.